Look up at the night sky on a clear, dark evening, far away from the blinding lights of the city. What you see is a canvas of black, speckled with thousands of glowing dots. It feels vast. It feels infinite. But what you are actually looking at is just our immediate cosmic neighborhood. You are seeing a tiny fraction of the stars within our own Milky Way galaxy. To truly understand the scale of the universe, we have to look past what the naked eye can see. Our Milky Way alone contains an estimated 100 billion to 400 billion stars. Let that number sink in. If you were to count one star every second, it would take you over 3,000 years just to count the stars in our home galaxy. But the Milky Way is just one galaxy. Thanks to modern telescopes like Hubble and James Webb, we now know that the observable universe contains roughly 2 trillion galaxies. 2 trillion galaxies, each with hundreds of billions of stars of their own. Now, let's do some basic math. Let's assume that planets are common, which we now know they are. Let's assume that only a tiny fraction of those stars have planets in the habitable zone, the Goldilocks zone where water can exist as a liquid. Even with the most conservative, pessimistic estimates, there should be billions, if not trillions, of Earth-like planets out there. Planets with the right temperature, the right chemicals, and the right conditions for life to begin. Given the age of the universe, 13.8 billion years, there has been plenty of time for life to evolve. Our own solar system is only about 4.5 billion years old. If life can happen here, it should have happened millions of times over across the cosmos. Civilizations should have risen, mastered their environments, and begun traveling among the stars long before Earth even formed. By all logic, the universe should be teeming with life. It should be a bustling, noisy metropolis of alien empires, trading routes, and cosmic megastructures. We should be seeing their radio signals, their laser communications, or the shadows of their giant engineering projects passing in front of stars. And yet, when we point our most powerful radio telescopes at the heavens, what do we hear? Nothing. Absolute, deafening silence. This contradiction, the high probability of alien life versus the complete lack of evidence for it, is the core of one of the most terrifying questions in science. In the summer of 1950, physicist Enrico Fermi was walking to lunch with his colleagues. They were discussing a recent cartoon about aliens, and the conversation drifted to the vastness of space. Fermi suddenly stopped, looked at his friends, and asked a simple, profound question. Where is everybody? This question became known as the Fermi Paradox, and the answers to this paradox range from the fascinating to the deeply disturbing. To understand why the silence of the universe is so problematic, we have to look at the Kardashev scale. Proposed by Soviet astronomer Nikolai Kardashev in 1964, this scale categorizes intelligent civilizations based on how much energy they can harness. A Type 1 civilization can harness all the energy available on its home planet. They can control the weather, mine the oceans, and utilize every drop of sunlight that hits their world. Humanity is not even a Type 1 yet. We are currently at about 0.73 on the scale. A Type 2 civilization can harness the total energy output of their host star. To do this, they might build a Dyson sphere, a massive megastructure that completely encloses their sun to capture all of its radiation. A Type 3 civilization can harness the energy of their entire galaxy. They would be immortal, god-like beings, capable of manipulating black holes, moving star systems, and bending the fabric of space-time. Now, consider the timeline of the universe. If an alien species started just 1 million years before us, a mere blink of an eye in cosmic time, they should have easily reached Type 3 status by now. A Type 3 civilization expanding across the Milky Way, even using slow ships traveling well below the speed of light, could colonize the entire galaxy in a few million years. Their presence would be impossible to hide. The infrared heat signatures of their Dyson spheres would light up our telescopes. Their communications would flood our radio receivers. But the sky is empty. So, where are they? Over the decades, scientists, philosophers, and astronomers have proposed dozens of solutions to the Fermi Paradox. Let's explore the most prominent ones. Solution number 1. We are simply listening wrong. The universe is incredibly vast, and searching for a specific radio frequency is like trying to find a needle in an ocean, not just a haystack. Perhaps advanced civilizations don't use primitive radio waves to communicate. Maybe they use lasers, neutrino beams, or quantum entanglement, technologies we barely understand, let alone know how to detect. Imagine a remote tribe in the Amazon rainforest trying to tune into a modern Wi-Fi signal using a wooden drum. They would conclude the air is silent, completely unaware of the invisible data flowing all around them. We might just be that isolated tribe. Solution number 2, the zoo hypothesis. This theory suggests that highly advanced alien civilizations do exist, and they know exactly where we are. However, they have chosen not to interfere with our development. They treat Earth as a protected wildlife sanctuary, observing us from a distance without making contact. Just as we wouldn't walk up to a colony of ants and attempt to teach them calculus, an advanced civilization might view us as too primitive to engage with. They are waiting for us to cross a certain technological or moral threshold before revealing themselves. Solution number 3, the dark forest theory. This is perhaps the most chilling answer of all, popularized by the science fiction author Liu Cixin. Imagine the universe as a dark, dense forest at night. Every civilization is an armed hunter stalking through the trees like a ghost, gently pushing aside branches, trying to make no sound. In this forest, survival is the only goal. If a hunter discovers another life form, another civilization, they have no way of knowing if that civilization is hostile or peaceful. Because of the vast distances and the impossibility of rapid communication, a chain of suspicion is formed. The only logical, safe move for the hunter is to immediately destroy the other civilization before it becomes a threat. In this scenario, the universe is silent not because it is empty, but because everyone is hiding. Emitting a radio signal into the dark forest is the equivalent of lighting a bonfire and shouting, "Here I am!" If the dark forest theory is true, our current attempts to broadcast messages to the stars are dangerously naive. We might be drawing the attention of an apex predator that we cannot even comprehend. But there is another theory, a theory that doesn't rely on hiding aliens or technological misunderstandings. It is a concept so profound that it dictates the ultimate fate of every living thing in the cosmos. It is called the Great Filter. Introduced by economist Robin Hanson in 1996, the Great Filter theory suggests that there is a severe barrier, an incredibly difficult hurdle in the evolutionary timeline, that stops life from advancing to a galaxy-spanning civilization. It is a biological or technological bottleneck that almost no species can survive. The Great Filter demands that we look at the evolutionary path from a dead rock to a multiplanetary empire. This path requires several incredibly unlikely steps. First, you need the right star system and a habitable planet. Then, non-living chemicals must somehow assemble into self-replicating molecules, the spark of life. Then, simple single-celled life must evolve into complex multicellular life. Then, that life must develop high intelligence, invent tools, and create a technological civilization. Finally, that civilization must survive its own technology long enough to conquer the stars. The paradox exists because one of these steps must be practically impossible. The terrifying question is, where is the filter located? Is it behind us, or is it ahead of us? Let's assume the Great Filter is behind us. This is the optimistic scenario. It means that one of the evolutionary steps we have already passed is so incredibly rare that it almost never happens anywhere else in the universe. For example, maybe the transition from dead chemistry to the very first living cell, abiogenesis, is a freak accident that requires such precise conditions that it has only happened once in a trillion star systems. Or perhaps the leap from simple bacteria to complex eukaryotic cells with a nucleus was the filter. On Earth, life remained single-celled for billions of years before making that leap. If the Great Filter is behind us, we have won the ultimate cosmic lottery. We are the rare exception. Humanity might be the very first civilization in the Milky Way, the elder race, destined to be the ones who eventually colonize the galaxy. The universe is silent because we are the only ones here capable of making a sound.
But what if the Great Filter is not behind us? What if the emergence of life is common? What if climbing from bacteria to animals, and from animals to tool-building civilizations, happens all the time? If that is true, then the Great Filter is still ahead of us. This is the nightmare scenario. It means that countless civilizations have stood exactly where we are now. They built cities, split the atom, explored their moon, and looked up at the stars, wondering if they were alone. And then, something stopped them. Something wiped them out before they could become a Type 3 civilization. And whatever destroyed them is waiting in our future to destroy us. What could an onward Great Filter be?
Discovered nuclear weapons less than a century ago, and we have already come perilously close to annihilating ourselves multiple times. But nuclear war is just one possibility. An advanced civilization might create a highly infectious, bioengineered supervirus that escapes the lab. They might inadvertently destroy their planet's biosphere through unchecked climate change and resource depletion. Or, perhaps the filter is artificial intelligence. A civilization might create an artificial superintelligence that realizes its creators are inefficient or a threat, leading to the rapid extinction of the biological species. The AI might then decide that expanding across the galaxy is illogical, choosing instead to remain dormant and compute internally, leaving the universe looking dead to outside observers. It could even be an experiment in physics gone wrong, an attempt to harness the power of black holes or a particle accelerator experiment that accidentally triggers a vacuum decay, a cascading bubble of destruction that wipes out the entire star system at the speed of light. If the Great Filter is ahead of us, then the silence of the night sky is not empty space, it is a graveyard, a museum of failed species that reached a certain level of technological adolescence and pulled the trigger on themselves. This is why, strangely, discovering complex life on Mars or finding fossils of fish in the oceans of Europa would be the worst possible news for humanity. If we find independent life right next door in our own solar system, it would mean that the genesis of life is incredibly common. It would mean the Great Filter is definitely not behind us. It would mean the barrier that destroys civilizations is lurking in our near future. As the philosopher Nick Bostrom has said, in the search for extraterrestrial life, no news is good news. The Fermi Paradox forces us to look in the mirror. We are a young species. We have only had electricity for a few generations. We are just taking our first fragile steps off our home planet. We are currently navigating a minefield of existential threats: climate change, nuclear proliferation, autonomous weapons, and unaligned AI. We are standing at the most critical juncture in human history. The next century will determine if we pass the Great Filter, or if we join the silent ghosts of the cosmos. If we are indeed alone, if the entire observable universe is devoid of other conscious minds, then that makes humanity infinitely precious. It means the universe has only one way to experience itself, to understand its own beauty and complexity, and that way is through us. Our fragile blue planet is the only vessel of meaning in an endless sea of dark matter and radiation. We have a responsibility to survive. We have a responsibility to overcome our petty conflicts, to protect our biosphere, and to push outward into the dark. We must become the aliens we are searching for. We must bring life to the dead rocks of the Milky Way. The silence of the universe is not necessarily a void. It might be a blank canvas, waiting for us to paint the future. Thank you for joining me on this journey into the unknown. If this exploration of the Fermi Paradox made you look at the night sky a little differently, please leave a like, subscribe to the channel, and share your thoughts in the comments below. Where do you think everyone is? Is the Great Filter ahead of us? Or are we truly alone? Until next time, keep looking up.